Hello friends, welcome to this new video on inverse Laplace transform. What is inverse Laplace transform? So for that we need to know what is meant by Laplace transform. So we know that the Laplace transform for any function f of t is defined as 0 to infinity e power minus st f of t dt, where t is going to be greater than or equal to 0. Inverse Laplace transform is nothing but the reverse function of it. So what do we mean by reverse function? Say suppose this Laplace after we compute, we will be getting a function of s. Because all our t will be eliminated, we will be substituting the limit for my t, and what will be left out is going to be a function of s. So I can say that Laplace of my function f of t is going to be some function which is f of s. Now, if I want to extract f of t back, then what I'll have to do, what I will do is, instead of operating by the operator L, which is Laplace, I will try to operate it by Laplace inverse. Your inverse Laplace transform operator is denoted by the symbol L inverse. So when I want to get this f of t back from my Laplace, what do I do is, I apply inverse Laplace to my function f of s. So we can say that it is nothing but the reverse of what we do for our Laplace. So when we do the reverse or the inverse function, what we get back is our function f of t. So all the values when we get for our inverse Laplace will be in terms of the variable t. Notice when we took Laplace, what was the output in terms of the variable or the parameter s. When we take inverse Laplace, it will be in terms of the variable t. Now, we already learnt about some basic formulas of Laplace. We will see how to derive the inverse Laplace formulas from those. The basic formula for Laplace of e power minus at is 1 by s plus a. So when I want this e power a minus at, what do? I operate it with inverse Laplace. So when this L goes to opposite side, it becomes, or it acts as a Laplace inverse. So Laplace inverse of 1 by s plus a becomes e power minus at. So can we say what is Laplace inverse of 1 by s plus 3? So this will be e power minus 3t. What we know about Laplace of e power at? It is 1 by s minus a. Notice if it is positive in the exponential, it will be negative in your function of s. If it is negative in the exponential, it is positive in the function of s. So when you take this L to the opposite side, Laplace inverse of 1 by s minus a is e power at. So what can we say about Laplace of 1 divided by s minus 3? It will be e to the power of 3t. Next, we know Laplace of sine at is a by s square plus a square. So take your Laplace to the opposite side. Laplace inverse of a by s square plus a square will give you back your sine at. So what can we say about Laplace of 5 divided by s square plus 25? So this is nothing but sine 5t. Laplace of cos at is s by s square plus a square. So when you take Laplace inverse on both sides, s by s square plus a square gives cos at. Hence, what can you say about Laplace inverse of s by s square plus 25? So since s is there on the top, it will be of the opposite sign. You can remember in this way, it is cos phi t. Sine has a constant in the numerator, cos as a s in the numerator, cs. Okay. So next, we know Laplace of sin h of at is a by s square minus a square. So what is the difference between sin and sin h? In sin h, the denominator has a negative sign. In sine, you have a positive sign. So that is the basic difference. Now when you want the Laplace inverse, you retrieve back your sin h of 80. So what will be Laplace inverse of 3 divided by s square minus 9? So this will be sin h of 3t. Okay. Laplace of cos h of 80 is s by s square minus a square. So what will be Laplace inverse of s by s square minus a square? It will be cos h of 80. Hence, can we find Laplace inverse of s by s square minus 16? Yes, you are right. It is cos h of 4t. When you have s, this has to be c. You can remember it in this way. Now, how about Laplace of a constant? Laplace of a constant is k by s. Now assume this k takes the value 1. So what will be Laplace of 1? Laplace of 1 will be 1 by s. So when you operate it by Laplace inverse, what will be Laplace inverse of 1 by s? Yes, it will be 1. Now this is for s with power 1. What happens when you raise it to the power n? So we know that Laplace of t to the power of n is n factorial by s power n plus 1. So when I want Laplace inverse of the function s, what do? I cross multiply it to the opposite side. So Laplace inverse of 1 divided by s power 5. Can you guess what is this now? We now have n plus 1 as 5. So what will be n? It is 5 minus 1, which is 4. So what will be the answer of Laplace inverse? T power 4 by 4 factorial. So this will be your answer for Laplace inverse. Say in case you don't have a constant in your numerator, but you just have a 1. That is like Laplace inverse of find 1 divided by s square minus 9. Say the problem is like this. We know that Laplace inverse of a by s square minus a square is only sin h of 80. Laplace inverse of a by s square minus a square is sin h of 80. So what is missing in my numerator? A is missing. So when I write this, I can rewrite this as 1 by s square minus 3 square. So in which case my numerator requires 1 3 to apply this format. Since it is missing, what do is I multiply by a 3 and divide by a 3 to balance it. Now what happens? This parenthesis is ready for the application of Laplace inverse. Hence, when I apply Laplace inverse to this brackets, what I will be giving? You will be having sin h of 3t. Hence, the extra 1 by 3 which you multiplied and divided by for balancing the numerator will be acting like a constant. So, don't worry if you have no number in the numerator. Just multiply and divide by the required component and then adjust the factors. Then you will be getting your answers. Can you try Laplace inverse of 1 divided by s square plus 16? Yes. What can be done about this? It is Laplace inverse of 1 divided by s square plus 4 square. What I want in the numerator is a 4. But this 4 over here is missing. So what do? I multiply by a 4 and I divide by a 4. The divide by 4, I take it outside the Laplace since it is a constant. So now it is 1 by 4 times Laplace inverse of 4 divided by s square plus 4 square. Since it is going to be plus, what is the quantity? Is it sine or hyperbolic sine? Yes, it is going to be sine because constant means yes. And if it is plus, it is going to be sine. If it is minus, then it is hyperbolic sine. So you have this as sine 4t. Hence the answer for this component will be 1 by 4 sine 4t. When you have a series of components, like say find Laplace inverse of 1 by s to the power of 5 plus 1 divided by s squared plus 16 minus s divided by s squared minus 9, then what can we do? Since we know that the Laplace operator is linear, so is the inverse Laplace operator. Hence, I can split them as Laplace inverse of 1 by s plus s power 5, Laplace inverse of 1 by s square plus 16 minus Laplace inverse of s by s square minus 9. So now for individual components, I can apply inverse Laplace to get the answer as 1 by s power 5 gives you t to the power of, so s to the power of n plus 1. N plus 1 is 5. So what is n? N is 5 minus 1, which is 4. So this is t power 4 divided by 4 factorial. Next, to apply Laplace to this quantity, the 16 is nothing but my s square plus 4 square. What is missing in the numerator? 4 is missing. So I multiply and divide by 4. So this gives me 1 by 4 times of, so since it is constant, it has to be sine. And since it is plus over here, you know that it is going to be sine of 4t. Next, since it is s over here, you know that it is going to be cos. So the next term will be cos. But since there is a negative sign in the denominator, you need to know that it is hyperbolic cos. So this becomes cos h of 3t. Hence, when you have a sequences of terms, you can apply Laplace inverse to each and every term individually and then get your required answer. Thank you.